Combination is when the order does not matter. So for example, if you have 10 toppings to choose from when you order a pizza and you're choosing 3, does it matter whether they put sausage, pepperoni, and pepper versus putting pepperoni, sausage, and pepper? You see what I mean? So does the order matter? If your mom ordered in a different way, does that mean you're going to get different pizza? No. So those types are called combination because the order does not matter. Do you guys see the difference? Permutation, the order matters. For combination, order does not matter. So then, what you need to do, there will be less outcome with combinations. So you divide it by r factorial again. That's the difference, okay? So let's look at an example. So here, permutation means the order matters, right? So is getting E and F different than getting F and E? Hope no one gets failed and E, but you see how they're different? They're counted as 2. But combination, again, the order doesn't matter. So EF is same as FE. So we just count it as 1, so you get only half of what you're getting here. Why? Because you have to divide by, when you're choosing 2, you have to divide by 2 factorials again for combination. Do you guys see the difference between permutation and combination? Combination, order does not matter. Permutation, it does matter. So what about this one? At Grant High School, there are 15 names on the ballot for junior class officers, and 5 are selected to form a class committee. Just 5 are chosen for the committee. Does the order matter? No, they don't have different rules, so it doesn't matter if I choose you first versus her, because it's just 5 total. They don't have different rules. So this is combination. So what do? It is 15. Now you can say combination 5 or 15 choosing 5, which is 15 factorial divided by 15 minus 5 factorial divided by what? 5 factorials again. No, this number. It was 2 from the previous question. That's why we did 2 factorial. This one we're choosing 5, so you have to divide by 5 factorials. So first, let me show you how to do this by hand. Guys, write this down. So 15 factorial is 15 times 14, 13, 12, 11, 10, 9, dot, 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 dot. I'm going to just write dots. Why? What is 15 minus 5 factorial? Isn't that 10 times 9 times 8 times dot, dot, dot? That means these are all gone. You see it? Now I have 5 factorials left. So I can put 5, 4, 3, 2, 1. You don't have to write 1. So here you can do it by hand. What's 15 divided by 5? 3. What's 3 divided by 3? Gone. What's 14 divided by 2? 7. What's 12 divided by 4? 3. So you're just doing what? 7 times 13 times 3 times 11. Right? So make sure you know how to solve these by hands. So what was it? It was 7 times 13 times 3 times 11. 3003. 3003 different ways, different committees, right? So let's just use a calculator to do 15 choosing 5. 15 math probability. Now it's 3.
You got 3,003 ways?
Yes.
How? Wasn't it 3 times 7 times 13 times 3?
7 times 13 times 3 times 11.
Oh, times 11.
Yeah. So you see how you can easily use the combination? So now here, how many ways can a committee of 5 be formed if each student have different responsibility? So would the order matter? Yes, right? One choosing for president, again, is different than choosing that person as a vice president. So this will be what? 15 permutation 5 which is 15 factorial divided by 10 factorial. So you get 15, 14, 13, 12, 11, 10, dot, dot, dot. And 10 factorial is what? 10, dot, dot, dot. So it's just these numbers multiply. Or just plug into the calculator 15 math probability and permutation choosing 5. You get 360,360. 360,360 different committees, right? You get more for permutations. Oh, last one. So again, at the same high school, there are 15 names on the bulletin for junior officers. 5 will be selected to form a class committee, okay? But the question is, if there are 8 girls and 7 boys on the bulletin, how many committees of 2 boys and 3 girls can be formed? So first, let's find how many ways can 2 boys be chosen from 7. Does the order matter? No. They're just choosing the committees, right? So how many can be chosen from 7 to 2? You're choosing 2 from 7. Order doesn't matter, so it's combination. So what do you get? Just plug into the calculator. So 7 math probability choosing 2. Wait. The order doesn't matter, so it should be combination. 7 math. Yes. So you get 21. How many ways can 3 girls chosen from 8? So 8, choosing 3. 8, math probability, choosing 3. So you get 56. So now, that wasn't the question, right? The question was how many ways 2 boys and 3 girls can be chosen together. Now, what do you do with these 2? Multiply. Now, it comes back to the basic counting principle. There are 2 events, boys and girls, and there are 21 outcomes for boys and 56 for girls. So the total different ways of choosing 2 boys and 3 girls will be 21 times 56. So this is a little more advanced than the ones that we did, but because you have to use combinations and then multiply them by using the basic counting principles.